If the line x cosine alpha plus y sine alpha equals to p is tangent to the circle, then find the value of p. So here we have a tangent whose equation is given by x cosine alpha plus y sine alpha minus p equals to 0. Now this tangent line is tangent to the circle, let's say at point P. Now our goal will be to find out the value of this constant p here. So let's begin. So here we will consider the equation of the circle. We have x squared plus y squared minus 12x equals to 0. From this given equation of circle, we will try to find out the radius as well as the coordinates of the center. All we have to do is compare it with the general equation of the circle, which is given by x squared y squared plus 2gx plus 2fy plus c equals to 0. And this is going to give us 2 times g will be equals to negative 12, which means that g comes out to be negative 6. Then we have 2 times f. So f value, that will be equals to 0, and the constant c, that's also 0. Now the coordinates of the center is given by negative g comma negative f. Now that means negative of negative 6 will make it positive. We have 6 comma 0. So that's going to be the coordinates of the center. And the radius of the circle is given by square root of g squared plus f squared minus c. So that means r comes out to be equals to 6 units. Now what we'll do, now that we have the coordinates of the center, see, so let's note it down. We have 6 comma 0. We'll try to find out the distance of the point C from the straight line. We're going to use a formula here. Let's say we have a point with the coordinates x1 comma y1, and we want to find out the distance of that particular point from a straight line with the equation ax plus by plus c equals to 0. Then we use the formula. The distance d will be equals to the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. Now in our case, we want to find out the distance of point C from the straight line with the tangent line. So we'll join C and P. So that means the distance CP, that's going to be equals to, we'll take the absolute value. We'll start with the coefficient of x, that's cosine alpha. This will get multiplied with the x coordinate of the center. So that's 6. We get 6 cosine alpha. Then we add it to 0 times the sine alpha value. So that means we have multiplied the y coordinate of the center with the coefficient of y, and then we have the constant negative p divided by the square root of, we have cosine squared alpha plus sine squared alpha. Now luckily for us, CP is nothing but the radius of the circle. And what's the radius? We've already obtained 6 units. So 6 is going to be equals to absolute value of 6 cosine alpha minus p, and in the denominator cosine squared alpha plus sine squared alpha, that is 1 because it's an identity. So let's solve for the value of p. Now since it's an absolute value, we're going to get 2 equations. One equation will be 6 times cosine alpha minus p will be equals to 6, and the other possibility will be 6 times cosine alpha minus p equals to negative 6, which means that p comes out to be equals to 6 multiplied to cosine alpha minus 1, and p can be also equals to 6 multiplied to cosine alpha plus 1. However, we know that cosine alpha minus 1 is a standard value. That's negative 2 times sine squared alpha over 2, which means p will be equals to negative 12 sine squared alpha over 2. And then we have 6 multiplied to cosine alpha plus 1. So that's also an identity with the value 2 times cosine squared alpha over 2. So we get 12 cosine squared alpha over 2. So these are the 2 possible values of p whenever the tangent line given by this equation is tangent to another circle.